Hello, today I'm going to do a problem about intensity and intensity level. So this is where we're talking about the loudness of different sounds. And one of the tricky things about this is that you have to keep in mind intensity level versus intensity. They're two different things, they have different units, they have different equations. So whenever you're doing problems about decibels, intensity level, all that stuff, remember intensity level, intensity. Keep those separate. So the problem I've got for today, the intensity level of a jackhammer is just at the threshold of pain, which is 130 decibels, when you stand 80 centimeters from the hammer. When you stand 130 centimeters away, what is the intensity level? So we know that when we're 80 centimeters away, it's 130 decibels, so it is right at the threshold of pain. And then when we increase from 80 to 130 centimeters away, what's going to happen to the intensity level? How loud does it end up going? So here we've got person standing, okay, loud thing. It's making noise there, that's a loud thing. And then we're going to stand a little bit farther away. And initially we're 80 centimeters away, and then we're 130 centimeters away. And we know here it's 130 decibels. Ooh, I'm going to have to keep track of units here. Centimeters, I got 230s to keep track of. And we want to know, when we're here, what is the intensity level? How many decibels? All right, so we know the intensity level in decibels at a certain distance. We want to know the intensity level in decibels at farther away. Okay, it's going to be smaller because we're going farther away from the source of sound. So we know it should be less than 130, which is good. If we went farther away and it got louder, not only would it be very unphysical, but it would also be over the threshold of pain. Okay, how do we do this? We want to know what is the intensity level at the farther away distance. We have the equation for intensity level, 10 times the log of intensity over a constant intensity naught. So in order to do this, I need my intensity. Okay. I'm going to start labeling this. I'm going to say this is at distance 1. All right, so to get intensity level, I need my intensity. I have an equation for intensity, and intensity is the power over the surface area. So intensity is power over surface area. Well, that means I need my area. Okay. So I need the area, and this is a sound wave. Sound waves are three-dimensional, so we're going to be using the area for a sphere, which is 4 pi r squared. All right, and I need my power. So how can I get my power? Now that's the power of the original source. The key thing to remember is that the power of the source doesn't change just because of where you're standing. So that's going to stay the same. So I need to know the power of the source. Well, I know information about the closer up situation. Can I work my way backwards, maybe? Can I get my power from knowing the intensity and the area? All right, so area 2, well, area 2 is going to be 4 pi r squared. It's still a spherical wave. Intensity 2, how can I get that? I can get intensity 2 because I know my intensity level. So I can get this from my intensity level at distance 2. So I have this, which means I can get this. I know my distance, so I can get the power, and the power of the source stays the same because it doesn't change just based on how far away you are from it. Once I have my power and my area, I can get intensity. Once I have intensity, I can get intensity level. So I'm kind of going forwards and then backwards. So let's do it. I need to get the intensity from my intensity level. So beta 2 is 130 decibels. And my equation is 10 log I over I naught. So I need to rearrange this equation for intensity. So I'm going to start by doing both sides, get rid of the 10, divide by both sides, 10. Okay, and now this is the step that a lot of people don't remember. The log is a function of 10, powers of 10. Log is telling us about powers of 10. So to get rid of the log, what you do is you raise both sides to the 10 10 to the both sides, I guess I'd want to say that. So if I do this, 10 raised to the beta over 10 equals 10 raised to the log of I over I naught. 10 raised to the log of something is getting rid of both of those. Just like the square root of x squared is x, 10 to the log of x is x. So these two get rid of each other. So I have 10 raised to the beta over 10. That leaves me just I over I naught. That I naught's a constant, multiply both sides. 10 to the beta over 10 equals intensity. Okay, so now I can get my intensity knowing my intensity level. In this case, intensity 2 is I naught, that's a constant, 1 times 10 to the minus 12, times 10 to the intensity level, which was 130 over 10. So that's my intensity level, that's my intensity at distance 80 centimeters. And when I do that, what do I get? That should get me 10 watts per meter squared. Yep. That makes sense. 10 to the negative 12 times 10 to the 13 is 10 to the 1. So, okay, now I have I2. Now I'm working backwards through my plan here. Now I should be able to get the power. So power is I2 times area 2. So it's 10 watts per meter squared times the area, which is 4 pi, times the distance squared. My distance, 80 centimeters. Look at that unit though. 80 centimeters needs to be converted to meters. 0.8 meters squared. All right, power, what do I get with that? 80.4 watts. So the watts stays on top, the meter squared, and the meter squared here cancel, leaving me just watts. Now I know the power of the jackhammer, so the power of the source. That's a constant. I now know that, so I'm going to go back to here. Let's get intensity 1. That is power over area 1. So 80.4 watts over my area, 4 pi, my new distance, 1.3 meters squared, and my new intensity, and just keep in mind, I'm farther away, I'd expect a smaller intensity. It had been 10, I want something smaller than 10, yep, 3.79 watts per meter squared. Okay, that makes sense, good. Now I have intensity, I can get my intensity level and solve the question. Beta 1 is 10 log I, which is 3.79, over I naught, the constant, 1 times 10 to the minus 12. And what do I get? I get 126 decibels. So is it less than 130? Yes, I went farther away. Smaller intensity level. Lower than the threshold of pain, but not by a huge amount. I mean, I was going from, 80 centimeters to 130, so not a huge distance away, but it went down. So we've answered the question. We have all the units and everything sorted out. I think we've got this one done. 2 things to note. The most common mistake I see is forgetting this 4. So when you're looking at the area, when you need the area in this equation or this equation, don't just jump to pi r squared. That's only for a circle. That's 2-dimensional. We are dealing with a 3-dimensional wave, and so we end up with 4 pi r squared. So the biggest mistake I always see, 4 pi r squared, forgetting that 4. The other big mistake that I see is getting to here and stopping. I want the loudness. I want the decibels, the intensity level. So don't stop here. I want to know how many decibels of loudness it is. So do that last step. And if you've got that, you've got your units all right, it makes sense with the answer, I think that's pretty good, right? Nice job.